Thank you. Yeah, today I'm going to talk about a product called Elasticsearch, which is basically there to search, but it's also there to analyze data and to use data in your enterprise. And my talk will for sure also include Hadoop, because no big data talk without Hadoop today, so be prepared as well. It's not just Elasticsearch. And I want to very quickly show you how you can basically work through the masses of data and use them for your company with a search solution. So I, for myself, I'm from Mimacom. I'm basically, I would call it a software architect or a client manager. I'm basically building solutions, also on Elasticsearch. We are currently working on 2 interesting projects that basically leverage the fact how to use data and to analyze them and to work with that. So today, Joscha gonna have a talk about project management, and there was one pretty good quote from Edward Deming. This is the Deming cycle. For sure you will hear something from him. And Edward Deming, just to give you a clue, he died 93. So he was saying, in God we trust, others must bring data. For sure at that time he did not know that today data is something like this, right? We have terabytes and terabytes of data. Just to give you a number, today it's forecasted that in 2 days we produce as much data as since the beginning of electronic systems to 2003. So you have to imagine in 2 days we produce quite a lot of data. And there are basically many ways to approach this. So one way is basically to try to work on that data. You will for sure hear a talk later by Pivotal how to work with big data on this, especially on Hadoop. But there is another way to try to leverage a search engine in order to do that. And basically the general benchmark for search engines is obviously Google. And I'm going to present you how to basically use the same way how we use Google today, and I'm going to show you how you can leverage Google already today to basically get insights of your data, of the public known data, and to use it for your enterprise, basically to see the insights of your data. So Larry Page was saying the ultimate search engine will basically understand everything in the world, and it will always give you the right thing. And this is what I want to try to demonstrate to you today, how to get the right thing out of your search engine. If we see Google, basically, it's familiar how to use that, obviously. So we have a search, but Google also have a very interesting part. It's called Google Trends. There, basically, you can see how things are evolving. And I want to very quickly show how search engines works and why they're particularly useful to get trends. Because search engines use one key concept. It's called terms. You can think about terms, it's like the registry of your book. Every book has, in the back, they have a terms registry, and there you can look up easily a word, and then basically you can directly jump to the page. And this is the general idea how Google works, and also other search engines like Elasticsearch. The general idea is you have some text, like here the quick brown fox jumps over the lazy dog, and basically the search engine has some techniques like analyzing and tokenizing and stores, let's say, the most important word, except for the stop words like the and a and so on. It stores them basically in an index. And then you as a user, you can just type in something like brown fox, and then you will obviously get the document. The people are pretty good used to live with the, let's say, not perfect match of a search engine. This is how we basically work also with Google. We don't expect that Google delivers one search result. We expect that Google delivers many, probably thousands. But the only thing that we really try to, or the only thing how we can work with Google is that most of the times Google will deliver the best search results on the top. So it does it by the PageRank algorithm, and the users are used to live with the, let's say, unperfect world. You every time have a distance. This is an eye tracking diagram. It basically shows in the Google Labs what they took, let's say, normal users, and they give them glasses which basically track your eye movements. And this is the result, basically, how people are used to use Google nowadays. So as you can see, the red flag basically means the people, they search something, and then they look at the first 2 or 3 search results. If they're not happy, then they just go back, type in something new, and then every time they stay on the first page and refine their search. Because that's the general idea. You don't expect to have an exact result like you have, for instance, in an application when you search something. You really expect to refine your search continuously and basically find the result. So Google will also help you, and Elasticsearch as well, is through auto-suggest. So even while typing, you can basically get support to search. There are pretty interesting sites outside what Google does suggest to you. That basically Google does it by analyzing the different searches and then suggesting that. So that if many people search something before you did, then Google will basically suggest that to you, because the likelihood that you want to search about that is pretty high. So there are funny things like, if you say, can a man get pregnant? Sometimes when I'm alone, I use Comic Sans. So there are pretty interesting searches out there. Is it impossible to lick your elbow? So before everybody starts trying, you can do it later. Or can Jesus microwave a burrito? So you can see how auto-suggest is pretty funny to analyze that. But the main goal is basically the search engine starts to get so intelligent that it can really help you to find the things on yourself. Now for search, I mean, everybody knows how to use that, but how to use the trends, the analysis of Google. There are a lot of papers out there that basically try to see how Google can help to predict things. And Google is particularly interesting if you want to understand how your market is going or how the public things are going. It's pretty interesting if you see, for instance, like hurricanes. If you go to Google Trends, you can just search for a time range, and then you can basically see when the hurricanes occurred, just based on the fact that you are seeing the peaks on the search queries. So you can go to trends.google.com, and then you can literally search about everything. It's pretty interesting. There are studies. So the University of Aachen in Germany, they did a study. It was a pretty long study. They tried to analyze how basically Google could have predicted the financial crisis. And if you go to Google Trends, it was basically the idea of the study. They entered 3 search terms. So they entered Lehman Brothers. I think it is known to everybody. They got bankrupt around September 2008. This basically marks the start of the financial crisis, so to speak. They analyzed the term subprime, and they analyzed the term financial crisis. And if you take these search terms, and then if you overlap basically the Standard & Poor's 500 stock market, so to see how the trades were going, basically they recognized patterns that every time when basically something is searched quite often in Google, like Lehman Brothers or financial crisis, the shares went down. So they analyzed quite a lot of data sets, and they recognized that basically, to say it in simple words, as much as you search about something, as much the share price will go down. So this was a study of the University of Aachen. Another insight on public data, which is pretty interesting, it's more IT related, obviously, is the Gartner hype cycle. Basically, every year Gartner publishes a hype cycle, and the hype cycle is something like to see basically at which stage the technology is currently progressing. And it is pretty accurate. So the people said that basically the Gartner hype cycle had foreseen the dot-com bubble at that time. So 99, basically, when they published their hype cycle, almost everything basically happened then 6 or 7 months later. The hype cycle basically have, in the beginning, the interest is growing, the expectations are very, very high, and then they go down because they face the reality. The people are starting to see what's possible and what's not possible with the technology, and then they go into the plateau of productivity. And the idea is, so I picked 3 technologies. The University of Washington basically also did a study, and they tried to find out how can Google basically match with the hype cycle of Gartner. And it's pretty interesting that if you take these 3 technologies, which are today, let's say, buzzwords, one is cloud computing, obviously, we see basically based on the hype cycle, it's going down, and it will then later on start to get into the plateau of productivity. We have big data, which is almost in the peak. That's why I'm talking today about big data. It's one of the most interesting things. And we see Internet of Things, so you have wearable devices, everything is connected as a, let's say, new coming trend. And if you take basically the Google search volume, you can map that, and they did it for around 40 technologies. So if you take Google, the result, you can basically see that the cloud computing is already starting to go down, because now the phase of illusion is basically going down. It goes then to the productivity plateau. We can see big data has a very, very big increase in the last time because it's moving to the peak of the hype cycle, and we can basically see that Internet of Things is currently ramping up, so the interest is going up as well. So I hope I provided you a couple of examples to see that basically, even though Google is only a search engine, it can really help you to see how the market is basically going. So you can go every time to trends.google.com and enter some search terms. You can enter basically the time period and then start and analyze things. So you could see how the market are going based on the products that you're offering. So the question is now, we have Google obviously for the public data, but I want to do that as well for my own data. And the question is, how can I use this data for my customers? So to see the data that I have and customers are asking me, for instance, if I have a search infrastructure at my place, can I see how the data is evolving? How can I use it for the employees, basically, the data that my employees are producing, or how can I use it with partners? So there is an open source stack. It's called ELK, Elasticsearch. It has a long, long history. The stack is basically a search engine, which is called Elasticsearch on itself. Elasticsearch is a full-text search engine based on Lucene. So you can easily think of that it almost can do everything what Google can do with your own data. So you can index the stuff, and then you can start using it. Elasticsearch is already used in quite a lot of places. For instance, if you go to Wikipedia or the social network Xing, if you go to SoundCloud, and all the other, let's say, big internet sites are already leveraging Elasticsearch for their sites. And we see customers starting to adopt Elasticsearch to index their data. And now the product itself also provides Logstash. I'm going to show Logstash later. It's basically a product that allows you to index all your log files and to search on them. And then there is Kibana, which is a dashboard, which you can then basically use to show graphs. I want to deep dive very quickly into this product set so that you get an understanding how these 3 things can help to build yourself, your little Google with Google Trends and all the analytics part. So, like I said, Elasticsearch is a search engine. It maintains an index comparable to Google. And what you can do now is basically you can start and feed your data into Elasticsearch. So you can have structured data. So structured data could be, for instance, a customer record, It could be anything out of your system, from your ERP system or whatever. It can be unstructured data, which might be, for instance, your log files. It can also be binary data like PDF and Word documents. So the general idea is that you start and index as much as data as you can afford or as you have in your company. Elasticsearch scales pretty well. I will go into the details later, how to basically make big installations on that. And now you can use Elasticsearch and do the same queries like you're used to do with Google. So for instance, I could now enter some search term on the top. It might be fuzzy, it might use a wildcard, it might be a boolean, so something car and Mercedes or something. So I can really start searching on top of Elasticsearch, and then I will get my documents. So this is pretty good, but I consider this as a, let's say, basic set or checkmark feature. So this is something every search engine have to provide it to you in some way. The one a little bit better, the one not so good. But this is also something that Elasticsearch does pretty well. Based on Lucene, it supports almost all the technologies that you know from the search engine space. It's like synonyms, so you can define different words for the same thing. It's basically stop words, it's stemming, so all the things can be done by Elasticsearch on itself. It's a server, so you can just configure it, start indexing it, and then ask for documents. So now the interesting thing comes up: how can you use Elasticsearch to create trends or diagrams? This is basically where Elasticsearch goes one step further. It does not only give you the possibility to search, you can also create statistics out of that. And this is called aggregations in the search engine. So you can think about, if you're used to use something like SQL, a group by statement, aggregations are almost the same thing on the search engine. So what you can do is basically you can say, give me please the stats for order amount. And stats is basically a keyword in Elasticsearch. It's a keyword in its language. And what you will get is basically you will get some statistics. So how many times do I have documents with the field order amount? What is the minimum value of the field, which is 60 here? What is the maximum value, which is 98? What's the average value, and what's the sum out of that? So you can really start and index your documents, and then you can ask Elasticsearch about statistics. So how many times and what are the values basically of this field? The query itself, it can be really Google-like, so you don't need to have an exact search. So here we are saying I want to search in the order amount. So I have documents that have some field called order amount, but you could do it Google-like, or you can basically extend it. So you can also say, okay, give me the statistics for the order amount where basically the stock is greater than 0. So you can almost use everything in the criteria. You can use a wildcard, you can use a phrase query, so everything what a search engine provides. And this is what I see one of the main benefits. You can use the, let's say, very weak or very open DSL of Elasticsearch and combine it with analytics and then get the data out of your application without to crunch every record, because Elasticsearch does that automatically for you while indexing. You can also ask, for instance, questions like, how many times is a field like the price missing in my documents? So I want to see basically where I have problems with my data. You can distribute the data on yourself, so you can basically say, okay, well, I want to get a range, and the range basically is 0 to 50, this is one bucket. I want to have another bucket 50 to 100, and the other one more than 100. So you can basically slice your data based on a field. So Elasticsearch will basically return you how many documents match based on these buckets. So as you can see, you can even define that dynamically, or the user could define that, and then Elasticsearch will return you the statistical data based on that. It goes further. You can bring the dimension of time into this. This is quite often a requirement, so you don't want to get only a snapshot regardless of the time of the data. You want to see how is the data progressing So there you can enter something like a date histogram. And the date histogram basically tells you how many documents are happening each day. So this is also something you can provide to a user in the search interface. So he can then see, okay, at which date did I basically have most of the documents? So he can also jump into a time range. So as you can see, it's not just about documents, it's really about time and data. The last piece that you can use is a geodistance query. So you can basically say to Elasticsearch, well, I want pizza, and I want it basically here. So it's a typical use case if you have a smartphone app and you want to search nearby. Or you could also search, what are my customers in Germany? You could do it in the geodistance way or geohashing way. There's also geohash support. And basically you can find out, where are my customers around 1 kilometers, 1 to 10, and more than 10 kilometers. So as you can see, you have a very powerful language and a powerful technique to basically do analytics on your data. So this is pretty nice. If you are an expert and you're used to do reports like group by and so on, you will be more than happy with this. But the question is basically how to analyze the data. What we see here is basically the text form. And this is where Kibana comes into the play. Kibana is basically a visualization framework, which is on top of Elasticsearch. It's a dashboard. And there were a lot of studies out there, what is better for the human being. If you go into the area of pattern recognition, the human brain is basically programmed, or basically the evolution taught us to use graphics. We are not so good to crunch the numbers. If we want to be exact, a number is good, but most of the people are basically doing pattern recognition when they see graphics, and then they can immediately recognize something is good, something is not so good. That's why we have in the car and in the plane cockpit, we all have graphical visualization of data, because we can grab that more easily than reading the number. And this is where Kibana comes into the play. Kibana is a very small application, but it is optimized to basically create dashboards for you and get the data that I have shown to you, get the data and visualize that. So you have Elasticsearch, you have Kibana. Kibana is a web application, so you call it in your browser. It's not something you have to install on yourself. And while using Kibana, you can basically start, create a query, which can be anything what you are taught by Google to do, so with and or and whatever. Then basically, you can filter a little bit your query, and then you can start to create graphs. So the data that I've shown you, based on the geo information, based on time, based on whatever, is then basically visualized to you into diagrams. You have different types of diagrams. So here you can see the distribution. And in the end, based on the small pieces, you can then basically create really powerful dashboards. So you can really start and create dashboards, and then you can basically see how the data is progressing and how the data is basically moving. A very powerful feature. We use that for customers who want to do monitoring. So based on the data that they index, they want to build dashboards, and then they can see how basically the type of data is progressing over time, over location, and whatever. So we see we have a very decent solution basically to show the data. While being at the graphics, I want to show you another dashboard. It's not from Kibana, and this is coming to my next point. It's about Logstash. Basically, Logstash is a solution that you can start to index your log files, and this comes pretty handy if you're using a search engine, because you can use Logstash to analyze your application state. This graphic here, it might sound or it might look nice, but this is unfortunately the biggest security breaches in the world until last year. The problem is basically there. If you read all the names, for sure you're also victim of one of them. And the idea is how to basically tackle security breaches into your system. One way is basically you should start and analyze your log files. This is what big companies are doing. It's basically keep your log files as much as you can, make them accessible so that even if something happens, you can retrospectively recognize when it started and when it hopefully ended. So this is a pretty interesting thing. That means fuel as much data as you can into your brain, into your company. And I did that as well. So I went to the system administrator of Mimacom and I was saying, well, I want to index the log files. And he was saying, well, we don't need Logstash for that. I can do it on yourself. So he came back with something like this to create my query. Here I created a script for you. But unfortunately, this is not a sustainable thing because you need experts to do that. You need to maintain it. And the most worst thing is if you go 2 weeks later, he says, well, I deleted the log files. It was not needed anymore. So I would not count on that. We need a solution, and this is basically Logstash. So you have Elasticsearch as your full text search engine. And then the idea is that you can get log files from your switch. It can be a syslog, for instance. You can get log files from your server. This can be an HTTP server, an Apache server. It can be a Tomcat. It can be literally everything that writes a log file. And then you have, for instance, a router which basically also produces logs, like a firewall that basically logs the intrusion alerts and so on. And the idea is to have a solution which allows us to basically index all these data so that later on we can go and search for that data. The solution here is Logstash. Logstash is basically there. It has around 80 input formats, so you can think about, you can use every standard log format, and then you just say, okay, this is an Apache log, this is a log4j log, this is a Cisco router log, and it's all predefined. So Logstash will basically parse your log files and tokenize them and push them to Elasticsearch. So with this information in the log files, you can now start with, for instance, Kibana and do analysis or do analysis on yourself. And one thing that I want to show you is this OWASP. This OWASP is basically a security alliance that basically published a top 10 list of security vulnerabilities. So basically you can see what are the biggest reasons for security breaches. The most important one is basically language injection. There's a comic like the mom is called by the school and she's saying your son entered as a name Robert, drop table students. This is language injection. So the people really start and try into the fields to add some data that basically harms your system. And there is a project called Honeypot. What they do is they do typical security analysis. And they did that a couple of years ago. It's already 10 years old. They opened an Apache server in order to find out what are the most common hacks that the people are using based on the OWASP guidelines. So the first one is injection, and most of the time you can see that in the log files. That's why Logstash is becoming important, because you see quite a lot of information already in your log files, just parsing the access log. And for instance, this language injection, you can see here, basically people try to send a form on the website, and then they try to enter data that basically harms your system. What we see here in the example, they enter exit because they want to kill your web server. If your application is not secured, it will basically stop. So this is something that you can do, and there are projects which help you to basically analyze your access logs, create a dashboard, and then you can see basically how many times people are trying to basically squeeze data which will harm your system. This is the top one priority. So the biggest security breach or the biggest security issue in internet applications is A1 in the list. It's called injection, so language injection. The second one is broken authentication and session management. So for instance, if you read the guidelines, it basically says you should never put session information on the URL because somebody can grab that URL from a log file and hijack your session. This is the second most vulnerability. And there you can also go with Kibana or Elasticsearch, and you can basically try to search for common patterns, For instance, in Java, you should not have a JSession ID with URL rewriting. It's pretty easy to set up something like this in Kibana and basically analyze the data. The third one is, before finishing, is basically XSS attacks. It's basically manipulating URLs and entering commands into the URL itself. This is more a vulnerability if your server is not safe. So if your Apache has a security bug or your Tomcat. But also here it's pretty interesting to find out basically what could happen. So people want to basically squeeze in commands into the URL itself. So as you can see, it's pretty interesting to get all this data and index as much as you can to get insights about this data. But still we end up with the same problem, too much data. So in the past, what we did in the last decade, what people are tempted to do is they just bought a bigger server, because the nice thing was the servers were getting faster and faster and faster. But there was one term coined a couple of years ago, the free lunch is over, by Herb Sutter. He's a pretty famous C++ developer. And what he was saying, basically, you don't need to improve the speed of your application. It just gets faster the whole time until 2005, because the CPU clock every time went faster and faster and faster. But at some degree, they stopped. And my boss at that time, 2004, he was saying, well, I think we don't need to do performance optimization. You can go to vacation, come back 1 month later, and the CPU will be faster, so your application will run faster at that time. But this stopped suddenly. This is why they say the free lunch is over. It's something around 2005. CPUs were not getting faster anymore. Basically, as an application developer, you could not rely that you just buy bigger boxes and the application will automatically go faster. So the way how you have to approach that, CPUs were getting more and more. You get more cores, while the clock speed is every time the same. So a CPU today is almost the same like 2 years ago. The only difference what they have is basically you have more cores and basically the caches and so on are improved, but the clock speed itself is the same. So the general idea is you have to divide. Divide and conquer, this is the basic idea. And Elasticsearch is really optimized to support this, so that basically Elasticsearch automatically, by default, if you have 5 servers started, it will automatically start and distribute the index to multiple pieces. So you can think of, if you have a 10 terabyte index, it will suddenly start and make it in 3 pieces like we see here. So this is basically to improve the amount of data that your servers can handle. But we want also to optimize the performance. This is the second part that Elasticsearch basically supports. It is called read replicas or read nodes. So basically you can start another 3 servers in this example. Then the reads will be done on the read nodes and the indexing time will be done on the master nodes. So also there you can basically improve the performance itself. And this is basically a general cluster setup which is supported also on cloud environments where we rely on software-defined networks. So it basically the clusters find each other, and then they start replicating themselves. And you can also manage these with Marvel, which is basically a tool which shows you the indexing speed, how many nodes you have, and to basically manage your cluster. What is the performance and so on. So I promised in the beginning there is no talk with Hadoop. Everybody is today at least claiming they have a Hadoop and that theirs is bigger than the other one. So basically Elasticsearch is not a replacement for Hadoop because it does a total different thing. But Elasticsearch is a perfect, let's say, extension to a Hadoop system. So if you have a Hadoop ecosystem, and Andre will today for sure show you what, for instance, Pivotal has to offer in this space. So a Hadoop distribution, you have a lot of tools which are perfect to work on big data. Elasticsearch is a very good, let's say, candidate to be used in conjunction with Hadoop. So together, so you can imagine you have Hadoop, and for instance, you have a MapReduce job. Elasticsearch can then be used to query inside your MapReduce job. So you can basically start, and in your MapReduce job, you have an input format, an output format, and you can query your search index and basically work on that data. I'm going to show you later on how this works on tools like Pig and Hive. Elasticsearch automatically works the same way through sharding, what I've shown you. You can work the same way like Hadoop works. So Hadoop works in input splits. That basically means if you have a file which is 10 terabytes, you have 10 nodes, every node gets 1 terabyte. The same is for Elasticsearch. You can also split Elasticsearch into 10 parts. So every input split has 1 shard on Elasticsearch. And this makes it also particularly scalable, even though you have a very, very high amount of data. So how can you use that? One, let's say, framework or technology based on the out of the Hadoop space is Hive. Hive is basically a document store which you can use to put in a lot of data and then query this data in a nearly SQL way. So you can basically get data, add it to your table, to your Hive system, and then you can query that. Elasticsearch allows you to integrate that so that you can basically use data out of your search index. You can basically use it together with Hive. This is a very, very high-level example. So Hive knows something about tables. You can create tables in Hive, which are basically backed by your search index, and then you can start and query the search index with Hive language constructs. So if you're doing already a big data project, you are already into Hive, you can basically integrate Elasticsearch into your Hive project. Another technology, so you might see basically Hadoop is pretty much, it's a zoo, it's about animals. So the last one is Pig. Pig is a high-level scripting language used in the big data space, so you don't have to program a MapReduce job. Pig will automatically basically translate the kind of DSL and execute that for you. And you have Hadoop, you then have Pig, and you can use Elasticsearch there as well. So it's just to show you how you could work with that is basically you can load data. So you have a big file set on your Hadoop file system, and then basically you can store it into your index. So if you want to do data ingestion, so you don't want to index the data on yourself to Elasticsearch, you want to use Hadoop because you have the data anyway there. You can then basically use, for instance, Pig, load the data, and just push it into Elasticsearch, and then make it searchable for your users there. Okay, so this hopefully gives you a very small overview how Elasticsearch, Kibana, and Logstash can be combined. It's like Percy said, you can have a lot of data, but data without information is nothing. So the general idea is basically with Elasticsearch to give you another tool in the big data space to be used by you to basically search for data. Okay, I'm done with my talk for now. I think we have a good time to do a couple of questions, 2 or 3 of them, if anybody has questions to Elasticsearch. It's early in the morning, I suppose. Okay, then I will close down my talk. I'm here the whole day, so if you have questions about Elasticsearch, big data, Hadoop, or the integration of that, feel free to ask me. Thank you.